Hey guys, this is Sebastian and welcome to today's session about OWASP Injections.
Now, why OWASP Injections? Well, because they are still the number 3 in the top 10 of the latest report from last year, 2021. And shockingly, 94% of all tested applications are still affected, even though they're actually quite easy to prevent. Now, what are injections actually? They are improper, restricted, or escaped input data. And there are a couple of variants of injections, which I will also show some examples of later. But some of them are, of course, NoSQL, SQL, cross-site scripting, also known as XSS, LDAP, and XML. Now, one example I would like to show is SQL injection. Now, SQL injection you might be familiar with is if you use a query and you just put in the input data with a simple string concatenation, for example. Now, in this case, the query retrieves me all products where the ID is equals to the request parameter ID. And you might think this looks harmless, but with this kind of style, it is possible to supply valid SQL in the parameter. Now, below I have an example. So here we are looking for the product with the ID 123, which might give us the ID, the correct product back. But if we add to the 123 some valid SQL, which completes, for example, the apostrophe, and we add another OR where 1 equals 1, we actually will select all products. Now, this is not a big deal, I guess, for this use case, I assume. But let's imagine we are talking about user accounts or order data that can be accessed like that. You might want to restrict it only to the user who has access to this data, right? Now, prevention is actually very simple. For queries, we just use parameterized queries. So how that usually works is that we replace the we replace the variable with a question mark or some kind of other identifier that the database uses, and we place the variable on the right. With that, we are actually safe because the query is being sent to the database and the parameters are sent separately. Another one I would like to show is cross-site scripting injections, the XSS one, which usually involves some kind of backend or front-end rendering of content. And in this simple example, I have provided a simple HTML which contains a template which renders out a variable. If someone supplies the request parameter name, this variable gets replaced and it should say this is my name X, right? Whatever has been supplied in the parameter. But let's say this is not properly escaped, or the template engine does not care for the escaping or the invalidating of harmful input, then we have a problem. So in this case here, I'm supplying just the name tester and it would render out the name is tester. This is my name tester. And if we are supplying, instead of such a harmless name, we supply a script like this, script alert surprise script, then if this is getting replaced here, we would actually have a script that is being executed and it would pop up the alert to the user. Now, that might not be very harmful, but you could maybe use this to steal cookies or other things from a user, which is not, which actually poses quite some risk because we are able to steal or hijack the session of another user. If this link, like this one here, for example, would be sent around to people, they click on this, they are logged in, and cross-site scripting is not prevented, then can be a big risk. Now, how do you prevent such a thing? Well, we just keep an eye on the template engine, that it renders out content in an escaped matter, such as it would replace these kind of informations here with safe HTML characters, and then we are okay. Now, I would like to show this now in a demo. I have prepared something. So I'm gonna have a look at SQL injection first. So I have prepared here now a users endpoint, which retrieves me 3 users. You can see here, Sebastian, Peter, and Michael. They're all users. They have been just recently created. And I've added here now our name parameter. And I can tell you, for example, search for Peter. So I just say Pete. And we find the Peter user. Now, if I were to supply the comma, you can see, oh, there's a problem, which means that now the SQL has having an issue, which indicates there's actually maybe an injection possible. So how about we supply now the content that I've just said. So let's do like 1. And suddenly we have all users here. You can see not just the user role, but we also have the the admin role available. I would like to show another thing, which is the cross-site scripting. And I've prepared here an endpoint which renders out some templating. This one also has the parameter name. Let's do here maybe SAP. That works. And if I were to supply now here script alert, the surprise script, this would actually, oh, this should be surprise. Oh, fair enough. Okay.
Now I've prepared a cookie which
cookie
could represent the user session.
And
in the following, this cookie will be stolen via a prepared endpoint.
Now
so
I've prepared an endpoint for that. So let's. Okay. Catch, and then equals. And then I think it was to be, and then document.cookie, and like that. Yeah, I think that should be it. If I execute this right now, you see nothing has happened, but actually something happened. And what just happened is that we have now here a fetch call that has been just executed, which calls another service. And you can see the payload should be my cookie, right? Document.cookie, which is this one here. Mystery session cookie. I've got nothing to hide. And this is also my cookie here, which is fair enough. And I can see that here on the backend. Okay, which is this one here. Just got a new cookie. No, they just caught a new cookie. Mystery session cookie. I've got nothing to hide. Okay. Now I would like to fix those 2 problems. And I'm going to show you my code now. So at first, let's tackle the SQL injection. And for that, I have here in the handle func users, I'm getting the name from the query. I'm giving the name to the getUsers function. I'm getting the users, rendering them out, and sending them out to the request. So we need to replace the query. So let's get into the getUsers function. And you can see I've already prepared some code for that. So here's the query. And at the moment, if the name is provided, I'm just adding the name with a like, which allows us to be affected by the SQL injection. Now first, I would like to remove this and then comment this one in. So you can see I've just replaced the name with a question mark. In the next step, we will need to still provide that parameter to the query, right? So let me just make an array here for the parameters and add the parameter. So this is then the same. So percent name percent is the same story here. And in the next part, let's make use of these parameters and remove the old code. Now, if I were to rerun this, let's give it a second. Okay. So if I'm going here, I rerun this, I receive nothing, which means that now the whole string is being sent away and I cannot use it anymore to find me because, or find Peter, because of course it's too much. No, sorry. Let's test this. And there's nothing anymore. So now the whole string is getting sent away and I would need to remove everything that I've sent to receive my previous result. Okay, that's it for the SQL injection. Let's have a look at the cross-site scripting. And that is in fact a bit easier with Go and how I have built this right now. So let's have a look how this works at the moment. So here, this works as following. So we have a name here that's being set to test by default. And if the name via the query parameter has been given, it's overwritten. So that's for the name definition. In the next part, we have a template, which is just simple HTML body, the h1, welcome to the server, and my name. Oh, this should not be necessary. Okay. And right. So in the next part, I would like to fix the cross-site scripting injection. So let's have a look at the code for that. So here in the HTTP handle func, I've got the name, which is being placed here. By default, it's test, and it can be overwritten by the query parameter. Here's the template definition. So we have HTML body, h1, h3, and here my name is ... will be placed by this here. So this t.execute is replacing this with whatever is sitting in name. Now, how do we actually fix this? And the clue right now lies in the kind of template engine what to use. So at the moment, I by accident used the text template import, and if I replace this with the HTML template, I would use a template engine which automatically escapes text to be not to invalidate harmful content for XSS. So let's restart this and have a look. So if I were to send this, and voila, now we have the full string here, which means it's not being executed anymore, and we have protected ourselves now against the SQL injection and the cross-site scripting. That's it from me, and I hope you have learned something. Thank you for your attention. Bye bye.